In this video, we'll define the class circle, and then we'll create two objects of the type circle and work with those two objects. To define the class, we first go right before the main function, enter the keyword class followed by the name of the class circle, and then follow that up by open closed braces. All the elements, everything in this class will be declared as public. That means that entities outside the class circle will have access to its elements. We are going to first list the data fields of the circle. This circle has only one data field. It is of the type double, and we're going to call the name of that data field as radius. Next, we'll list the functions in the class. Those functions will represent the behavior of this circle class. Among the functions are constructors of the class. The constructor of the class has the same name as the class itself. So here is the first constructor. We'll have two constructors for this class. Here is the first constructor. It receives no parameters. It is called default constructor. And here is the second constructor. This constructor receives one parameter. It is of the type double, and the name of the parameter is, let's call it new radius. Now the job of the constructor of a class is to initialize its data members. One last function in this class will have the getArea function, which returns a double type. The name of the function is getArea, and it basically computes the area of the circle and returns its value. So we are done with the definition of the class. The next thing we need to do is to implement the functions in this class circle. There are different ways to implement the functions in the class. One particular way is to implement them as an inline function. And this is the approach we're going to take for this particular example. So I'll go to the first function. That's the constructor function of the class. Enter the keyword inline next to it and implement this constructor right inside the class itself. So open braces, and this is the default constructor, and let's say that it will set the radius to a default number such as 1. That's the implementation of that particular function. We'll do the same thing for the second constructor. We'll turn it into an inline function implementation. Now this function, what it does, it basically assigns new radius to the data member radius of the circle. So it will assign to radius new radius. And that's the code for the second constructor. We'll now do the same for the getArea function. Turn it into an inline function. And the code for getArea is this function returns the area of the circle, which uses the formula pi r squared. For there's return for the pi, we'll use the approximation of 3.14. For r squared, we'll call the function POW, give it the radius and square it, and that's the code for it. So the class circle is defined, and functions in the class circle, all of them are implemented as well. We can now go to the main function and create two objects of the type circle. Keep in mind, when we define a class in C++, the class name becomes a new data type. So now let's create our first class. There is circle. The name of the class is C1 followed by semicolon, and then another circle object. There's the type circle, and the name of the object is C2, and it has argument of 5.5. So we have created two circles here. The first circle uses the default constructor to instantiate itself, to create itself. The second circle, C2, uses the constructor with parameter to instantiate itself or create itself. So C1 has radius of 1 and C2 has the radius of 5.5. We can take a look at the value of the radius, so I can actually print them out. So std : cout. We can look at C1 dot radius and \n. Go to the next line. I can copy that same statement, paste it, and then change C1 to C2. And also make sure to have system pause and return 0 if you're using Visual Studio, and run your code. What we would expect to see is the value of the radius of circle object 1 and then 5.5 for the second circle object. So it works fine. Now let's take a look at the getArea function. For example, let's look at the second circle and see what it returns for the area of the circle. C2.getArea and \n again, semicolon. I'll run this. So the area of the second circle is 94.985. It's good, it's working. Let me also show you one more item here. We can actually change the value of the radius in any of the circles, any of the two circles. For example, I can go to circle 1 dot radius and change the value of the radius to 100. And take a look at it to see whether it actually did change. So right here, I'm going to Control V it to print the radius for circle 1. I'll run it. And there it is. There is the radius of 100. Now, the reason you can do this is because the radius is declared as public in the circle class. Right? The reason you can actually use dot notation and access the radius data field in the circle is because, again, radius is declared to be a public data member. Therefore, we can use the dot notation and directly access the radius, either to look at its value or to change its value. If radius was not declared as a public data member, we could not have done this. So this is something to remember.